Welcome, students, to today's explainer. Today, we are going to master quadratic equations together. We will break this down methodically, step by step, so you never have to fear these equations again. Let's get right into it.
Created by Mindsticks Foundation Trust. Here is our agenda for today. First, roots and factorization. Then, completing the square. Next, the quadratic formula. And finally, choosing the best method. Let's begin with Section 1. Roots and factorization. Now, before we actually solve anything, we need to know what exactly are roots. Well, think of a ball thrown high up in the air. The roots tell us exactly when that ball hits the ground. Mathematically speaking, they are the exact values of our variable that make our quadratic equation equal to 0. Now, guessing these values, that just takes way too long. So let's look at the proper logical methods. Let's look at factorization first. You know, the core principle here is beautifully simple. If the product of two numbers is 0, well, at least one of them must be 0, right? So we find the product of the outer terms, split the middle term, factor out the common terms, and then we simply equate those linear factors right to 0. Let's apply this concept to an actual equation. Look at m squared minus 14m plus 13 equals 0. We are going to split that middle term into a minus 13m and a minus 1m. Factoring this gives us m minus 13 multiplied by m minus 1, all equaling 0. Equating these linear factors to 0, we find our roots are 13 and 1. It is quite straightforward, isn't it? Moving on to Section 2, completing the square. But here is a very practical problem we often face. What if we simply cannot find the factors easily? Take this equation, for example. X squared plus 10x plus 2 equals 0. It is literally impossible to find integer factors of 2 that somehow add up to 10. Simple factorization completely fails us here. So what is our path forward? Well, our workaround is actually very clever. We add a suitable constant term. Let's just call it k for now. We do this to forcefully convert the expression into a complete square. By expanding and equating the coefficients, we calculate that adding and then subtracting 25 beautifully converts the left side of our equation into the difference of two squares. And once we have that, we can solve it very easily. Now for Section 3, the quadratic formula. So, how do we actually get this famous formula? We absolutely do not just memorize it. No, we derive it logically. We apply the very same completing the square method we just learned, but to the standard form, ax squared plus bx plus c equals 0. By dividing both sides by a, we begin our mathematical journey to light the whole thing as the difference of two squares. This exact step-by-step logic leads us to a universal key, a key whose early foundations were actually laid down by the brilliant ancient Indian mathematician Brahmagupta. The final solution is x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. The two roots generated by that plus and minus sign are traditionally called alpha and beta. And finally, Section 4, choosing the best method. Let's put all of this into perspective with a side-by-side comparison of the exact same equation. On the left side, we use our factorization method. On the right, we use the quadratic formula. By comparing our equation to the standard form and just plugging in our a, b, and c values, you can see that both of these distinct paths lead us safely to the exact same roots, 13 and 1. The math, as always, is perfectly consistent. Having multiple mathematical tools truly empowers you. Whether you can quickly see the factors, need to complete the square, or just want to apply the universal formula, you now have the logical steps to succeed every single time. So the next time you see a curved bridge or a thrown object, ask yourself, what is the hidden quadratic equation at play here? Keep practicing your steps, and I will see you in our next explainer.